This is sort of a magic square question, except we don't know that the diagonals are also equal to the rows and the columns. So we just got to focus on the rows and the columns. Now I'm going to label this A to start with, and then the total is going to be A plus 10, looking across this row here. And then let's call this one B, and that is going to be B plus 15. So what that tells me actually is that A is equal to B plus 5. So I'm just going to replace it, I think, by B plus 5. Or I could do A minus 5, but it seems a bit nicer to just add it on. If I put C in here, then I'm actually going to also get it equal to, well, it's C plus 15 again. So in fact, C is equal to B. I didn't need to call it C. I'm just going to change it to B. But what I've got actually out of this is that the total then, I've managed to put B in 3 different places, although B plus 5 here. The total of all the rows in the columns is going to be B plus 15. Okay, that's great because that is going to allow me to write some of the rest down. So for example, this row here, I've got 11 plus B so far, so this must be 4. Whereas if I look at this row, I've got 12 so far, so it's got to be B plus 3. Okay, here, if I look now, I've got at the moment B plus 8, and so to get B plus 15, this is going to have to be 7. So I don't actually know what B is. I've not found it. I don't know if it's possible to find it actually, but it must be that in the shaded square it's 7. Let's just finish this off out of interest actually. So here this must be 1. Um, and now I've got, yeah, B. But actually I think there's an infinite number of answers for B. It will always work. Like whatever you choose for B, I can now make the rows and columns the same total. But the key thing is that this one is 7.